start with casting. So what is casting? Actually, when you're sending a packet from one host to any other host, that is known as casting. Okay, means I want to actually like communicate with another host. So how it will be? It will be like a whole. We discussed previously that we have a network. Inside a network, we have a host or a computer in like in normal terms, and then inside that we have a process. So one process want to communicate to another host, another network, on same network, whatever. Through to another host. Inside that host, there will be a process. So there will be process to process communication, but that is termed as casting. So if we talk about casting, there are two type of casting. One is known as unicast, and another is known as broadcast. Now, if we talk about broadcast, broadcast is further divided into two parts. So one is known as limited broadcasting, and another is known as directed broadcasting. Okay, so these are the three differences. So if you say about casting, so we have unicast, limited broadcast, and directed broadcast. So these are the three things which we'll be focusing on. Now, if you talk about like simply, if you talk about unicast, means that a host want to actually communicate to another host in another network. So again, let me draw this. These are two different networks, and we have a host. Let's say H1, and we have a host which is H2, and this want to actually send a packet to H2. So how can it send? It will create a packet, and that packet will have some data, and then it will have a source address and it will have a destination address. Yeah, we'll discuss about the details of this packet, how that packet is created in the later course of time. But for now, you see, there's a data, there's a source address. So let's say the source address is here is, let's say 11.1.2.3. And here the source destination address is 20.1.11.2, right? So this will go here, and this IP address will go here, and the packet would be transferred. Okay, so this is from a source to a destination. The next is known as the broadcast. So in broadcast, again, we have two types of broadcast. One is known as limited broadcast, and another is known as directed broadcast. So as the name suggests, limited means it is going to be limitedly broadcasting. Broad means there are a lot of hosts which through to which you want to send the packet. But again, lot of hosts, but it's limited. So how it is limited is, let's say, so this is of Unicast. Okay. The next is limited broadcast. So in limited broadcast, what happens is there's a network, there's a host, and this host wants to send to all the hosts of its own network. Means there would be other hosts as well in this network. And this particular host wants to send the information to all the hosts which is present within the same network. So within the same network. Okay. So this is known as limited broadcast. Now, why do we require broadcast? Why we can't go ahead with unicast? This is also one time, like what is broadcast? There are a lot of unicast, you combine them, it's a broadcast. If we talk again about class A. So for our class A, we had around to the power 24 minus 2 hosts, right? Which is nearly equal to how many millions? It was around 16 millions, right? They were around 16 million hosts, something like this. That is equal to 16 million hosts. So these many number of hosts you require to send. And if you set one by one unicasts, you can understand like how much hardware and how much software intervention would be required. There would be so much to send, right? But when we have limited broadcast, it is just one message which is being sent from the host and it gets forwarded to all the hosts present in the network. Otherwise, if you would have to send unicast to all these hosts, let's say of class A, it would be so much hectic for the host. Let's say this host is host 1. It will be so much hectic for host 1 to send one by one to these many 2 to the power 24 minus 2 hosts. That's so much. So a lot of hardware, lot of software, like it will take so much of time. Therefore, this limited broadcast is used. Now, just as a limited broadcast, you will easily able to guess what is directed broadcast. So directed broadcast means a host from one network wants to send the message or the packet to another to all the host of another network. So this is within the same network, but when we have directed, directed means it would be just that it is going to send to all the host, right? So we have a network and we have a host here. And this host want to send the packet to all the hosts of any other network. So this is another network. Again, it is, but in a different network. So that is known as directed broadcasting. Now, this is pretty much clear how we are sending. Again, here what will happen is this host 1 would be able to send only one packet with something known as directed broadcast, and that packet will be delivered to all the hosts which is present in network 2. That is known as directed broadcasting. But how do the routers or how do the internal mechanism work? Like how do I know that, okay, this packet needs to be sent to all the hosts present in that network? Or when it is limited, okay, I'm sending a packet, but this is a limited broadcast. So it needs to be only sent to all the hosts which is present inside my network. And third is, okay, I'm sending a packet. I have a source address. I have a destination address, but it needs to be given only to this particular host. So for all this differentiation, we use the two IP address that I said that they are not used in class in all the networks, right? I told you there are two IP addresses which are not used. They are reserved. So they are reserved for this only, this purpose only. They are reserved for limited and directed broadcasting. Okay. So the limited and directed broadcasting happens to those two IP addresses. We will be studying in detail now about what are those two IP addresses and how it is done. So we understood the use of limited and directed broadcast and unicast as well. Now we'll understand about it. But before going there, we'll talk about the network ID. Okay, so we know that there's a network in which there are a lot of hosts and all hosts have certain IDs, IP addresses. So let's say we have 22.1.0.5. Then we have 22.1.0.6, 22.1.0.7. So you see, these are all IP addresses. Can anyone can you guess which class this all IP addresses belong to? Any answers? Which class all these three IP addresses belongs to? How can you check like this IP address is belonging to which class? What is the range of IP addresses from class A? These are three IP addresses. Now we look at class A. So if you see class A, the format of class A is what? First bit would be 0 and all the rest 7 bit can be anything because the first 8 bits are network ID and then we have these 8 bits as host ID part. So we are not concerned about the host ID part. We are concerned about this. So it will start from 0, 0, 0, 0, 0, 0, 0, and it will end to 1, 1, 1, 1, 1, 1, 1, right? This is the class A domain. So this is actually what? 0. And this is actually what? 127. This is 127. So the range is from 0 to 127. So any IP address whose first part ranges from 0 to 127 is considered as class A. Simple, right? The range of class A network ID is from 0 to 127. So if we have any IP address whose first part, first 8-bit into decimal is between 0 to 127, then that belongs to what? Class A. Similarly, for class B, it would be what? Class B, we have 1, 0, and then we have followed by 6 bits. 6 bits, right? And it is next is what? Till 1, 1, sorry, 1, 0. Again, then there will be 6 bits. So if you see, it is what? Here we have what? 0, 0, 0, 0, 0, 0. And it will end till what? 1, 1, 1, 1, 1, 1. Also in class B, we have these 8 bits as reserved for network ID part. But we are just going to see the first part of the IP, the first 8 bits of any IP address which is given, and we can easily determine if it is class A or class B or class C or class D. So here if you see 1, 0, so it is what? 1 is what? It is 128, right? And this is what? 128 plus this. 1, 1, 1, 1, 1, 1, 1, 1. This would be 63, right? 1, 2, 4, 8, 16, 32.
Yes, we have 191 available.
191, exactly. So this is going to be 191. So if any IP address giving to you, the first 8-bit in decimal is ranging from 128 to 191, you can say it is class B. Now let's calculate for class C. Class C, we have what? 1, 1, right? And then 0 is reserved. And then we have how many bits? 4, 5 bits. And this will go till 1, 1, 0. And these 5 will be 1, 1, 1, 1, 1. So this is what? 192. Just one more, right? 192. Till it would be
223.
16, 8, 4, 2, 1. So if you add 192 with this, you'll get 223. So if any IP address, the first 8-bit decimal part is lying between 192 to 223, we can say, okay, it's class C. That's all. Class D and E is not required to calculate. You can calculate, but it's not required. So we'll focus on this. So class A, 0 to 127, class B, 128 to 191, class C, 192 to 223. So if we see all these 3 IP addresses, these 3 IP addresses belongs to class A, right? Now, so if it is belonging to class A, how many bits would be the network ID part? So according to class A, network ID is going to have 8 bits and the host ID part is going to have 24 bits, right? So the network ID. So let me say that these all IP addresses belong to one network, right? Because you see all these are having 22 in the starting. All these are having 22 in the starting. Therefore, it is belonging to one network. So the network ID of the entire network would be 22.0.0.0. Means, you see, you have this, right? And in this, we knew that we have 22.1.0.5, 22.1.0.6, 22.1.0.7. So all these will belong to a same network whose network ID would be 22.0.0.0. Means actually this network can be represented by an IP address, but which is 22.0.0.0. So it's just a way of representing the entire network with a specific ID. Therefore, this first 0.0.0 means all zeros are reserved as a network ID. I told you, right? So if we have this particular network, if we have like, let's say this, so how many IP addresses are possible? It will start from 22.0.0.0 and it will go till 22.255.255.255, right? So these are the number of IP addresses which are possible, but the first IP address is being reserved for the network ID and the last IP addresses I will talk to you about is also reserved. So the first and the last IP addresses means the network ID followed by zeros in the host ID part and the network ID followed by ones in the host ID part is being reserved, and all the other IP addresses are being used by the host present in that particular network. Means the host ID would be able to start with 1 and it will end till 255.254. So these are the IP addresses which will be available for the host to take that. Okay, so any host which is present can take any IP between these two, 22.0.0.1 till 22.255.255.254. But the entire zero, the entire ones are being reserved. The entire zero are being reserved for the IP addresses of the IP address of the entire network, and all ones are being reserved for another purpose. Okay, and so this is clear, right? What is the network ID? So this is the network ID. Now, if we talk about the direct broadcasting address, the last ID that I told you, which is having the network ID followed by the ones, this is reserved for broadcasting. Okay, and this is direct broadcast. So let's say I have an IP address of, let's say 12.1.2.3, and I need to send a packet in a direct broadcast manner to the network ID 22.0.0.0. Means that I will be using this as a source address and the destination address would be given as what? 22.255.255.255. If I this would be direct broadcasting. If I, let's say, need to have a unicasting to 22.1.0.7, then the source address would be the same. My address 12.1.2.3 and the destination address would be the IP address directly. That is 22.1.0.7. But if I have to make a direct broadcasting, means that this C, if we talk about the source, right? This source, what is the network ID of this source? So we'll first see which class it belongs to. It belongs to class A because it is the first, the 8 bits in decimal is representing 12. So it is class A. So class A means the network ID is only 8 bit. So the network ID of my network would be 12.0.0.0, right? Why it is a direct broadcast? Because the network ID in which I am lying and the network ID in which I want to send are two different networks. Therefore, this is a direct broadcasting. So my network ID is 12.0.0.0. I need to send to 22.0.0.0. Therefore, my source address would be my IP address, but my destination address would be 22.255.255.255. So whenever the entire ones are there followed by the network ID, it is marked as the direct broadcasting address. Now, next is we'll talk about next, which is limited broadcasting. So limited broadcasting means I have the network ID, means I have to send all the packets to my own network. So for limited broadcasting, so the source address would be the same, but the destination address would be the limited broadcasting of my own address. So limited broadcasting is 255.255.255.255 means when you keep all ones, in the destination IP address, it is referred as it is referred as limited broadcasting. Did you get this? So for any particular host which is present in any particular network, the limited broadcasting address is always same, which is all ones. But a direct broadcasting address depends on the network, and it's very logical. If you just keep your mind and just think over it. For direct broadcasting, we are actually sending to a different network. So if we are sending to a different network, we actually require the network ID, right? We don't require the host ID because broadcasting means we have to send to all hosts. So host ID is not required. Therefore, what we are doing is we are keeping the network ID part, and whatever is followed by it is kept as 1. But for direct, like for limited broadcasting, the destination address is not is it needs to be just all ones, because I know that okay, I have to send in my own network. And if I know my source address, I can easily find out what is my network. If I know the source IP, I can easily find out what do you say? We can easily find out the network ID which I am lying. But if I have to, like, therefore, when I have to do a limited broadcasting, I can all write all once and it will go to all. And therefore, again, we discussed in the previous lecture that there are two entire, what do you say, two network of class A which has reserved. So if you see, or you say there are two particular way which are being reserved. So this 255.255.255.255, which it will belong to class E. So that particular is always reserved. Similarly, 0.0.0.0 is also reserved. So again, those two networks are also removed from being used by the public. So for now, just keep this in mind, that the first IP address of the network is being used for the network ID part. The last IP address of the network is being used for direct broadcasting address. Therefore, two IP addresses are removed. So the number of effective hosts which is possible is the total number of IP addresses minus 2. That's clear. This is clear, I guess, right? Any doubts in this?